Hello everyone, so I'm Igal and I will be talking today about data artisans streaming ledgers. So you might have heard today during the keynote that we are announcing a new product today that allows you to run ACID transactions on your streaming data. And in this session, I will try to take the developer's perspective and actually explain what that is and show some code. And eventually leave some time for questions. So I would like to start with the following motivating example. So let's assume that I would like to create a financial service where I have accounts identified with an ID and a balance, and I would like to support the following operations. So I'd like to be able to deposit funds to account, find out what is the current balance of an account, and be able to transfer funds between accounts. So how would I do it traditionally? So traditionally, I will have something like a database where I would have like an accounts table with maybe 2 columns, account ID and a balance, just simplify it a little bit. And maybe I'll have a Spring application where I will probably find queries like that inside of my application. So to facilitate deposits, I will have an insert into statement. For the balance inquiry, I will have like a simple select. And for the transfer, I will have slightly more complicated an update statement where I'm kind of withdrawing balance from one account and depositing it to another account. And of course, this is a concurrent service, so we'd also we'll have to rely here on the database transactions. And I would like to also to spend one moment to talk about those question marks. So those are prepared statements, and essentially a prepared statement is a precompiled query that sits on the database side and allows us at runtime just to send the necessary parameters. So it might look like something like that, where we kind of see that the deposit is so we will be sending over the wire just those tuples of type varchar and bigint. And on the database side, we will have like something like this deposit precompiled query that accepts this tuple of parameters. Maybe it will have a key extraction thing here, and then it will issue a scan to get the actual value. So if we look at it for one moment, then we'll actually see that we have a typed stream of event, and we have a function that reacts to that on the database side. Now, if this looks familiar, this is because it is probably familiar because we are doing that all day long. I mean, we used to think about those typed streams of events as basically a data stream of, let's say, strings and long. And on the other side, we will have like something like an operator that accepts this event, maybe extract the key part of the event, and will access a state. But there are at least 2 major things missing here from a vanilla Flink application in the context of our financial service. So one thing is that there is no support for an intra-key state accesses, which means so usually inside of an operator we are bound to a specific key, and we don't have a way to extract, to use different keys, and in particular that might be keys that are sharded to different machines. So if I'm talking about the account state, account A might be in machine 1, and account B might be in a different machine. And we need this functionality for our deposits example. The second thing that is missing is that there's no transactions across multiple keys. So again, with the transfer example, when we like to transfer funds from account to account, if we want to stay consistent, we need an ability to have transactions that span across multiple keys. So So here comes data Artisan streaming ledger. And so what is it? Like the big picture is that it is a library on top of Apache Flink. It requires no additional dependencies. It seamlessly integrates and composes with the data stream API and SQL. So you can pipe the results to SQL if you want. And you can read and write to all of the Flink connectors that you all know and love. And it also supports save points for upgrades. So at that point, I would like to maybe show some code to actually explain how the things work. So let me start with the first example, where you can see here. I hope you do see it. Yeah. So so the first example, we can see here that we start just like as we would start any other Flink application, where we start by obtaining the execution environment. We might want to configure it. Let's say, I don't know, set up the parallelism or the state backend. And here enters, so this is the entry point to the streaming ledger. So we are creating a streaming ledger. We give it a name. And from now on, all the operations that will be performing on that ledger would be bound to that name. So it gives us like some sort of like a namespace that allows nicely encapsulate all the state and the transactional functions under that name. And we can, with that, we can also execute multiple ledgers within a single application. So the next thing that we will do in the context of our example, we will create we declare a state. So we do ledger.declare state. We again give it a name. And we say that this is a state of a key value type with keys of type string and values of type long. And at this point, I would like to point out that this interrupts with the normal serialization stack of Flink. So if you have your own custom POJO, if your own custom serializer, you just have to pass pass the correct type information or type hint here. And so we've defined the state. And the next thing that I would like to show is actually the transfers operation. So the next thing that we need is basically to obtain a data stream of those typed events. So here we have like something that generates those in memory just for the sake of the demonstration, but it is a normal data stream, so you can obtain it from your favorite message broker or whatever. And let me just quickly show what a transfer event is. So it is a POJO that has a source account ID, a target account ID, the transfer amount, and another parameter that I will speak in one moment. So the next thing that I would like to point out that we have here our business logic that we will execute transactionally, and I will show it in one moment. Because now, okay, so we have the business logic here, we have the data stream, we have the state access, now we have to wire everything together. So the way we will do it here, so we say, okay, ledger using a stream, that stream that we've defined before, we will apply our business logic, and now we have to specify what are the state accesses needed for our business logic. So the way to do that, we say apply on, and we pass here the account state that we've declared a couple of lines above. We have to also specify the how to obtain the key from the incoming event, so hence the method reference here. So this would be for our source account, and we also have to name it inside of our we also have to tie the result, the state access, so it can be identified within our business logic. So let's actually jump in here. So transfer handler would be a class with a function that we annotate with a process transaction, and it has the following signature. So the first thing you will see, it will actually expect the input event. The next thing would be the context, which I will address in a second. And the important bits here are the actual state accesses that we've defined before. And you can see that they are like wrapped within something that is called the state access. And it actually represents the rows of the source balance and the target balance. And the things that you can do with state access, you can read from it. You will get back the current source account balance and the target account balance, and you can also write the updated account balances. And let's go over the business logic here real quick. So we can also check some constraint violation. Like for instance, we might check that this account has sufficient funds, and if it doesn't, then we emit an event, and we say that this is not a successful successful transfer because insufficient funds. And otherwise, we do this complex arithmetic here with the minus and the plus, and we emit the event downstream. And this would be a successful event. And what is important to point out here that an invocation to this function will be transactional with ACID guarantees. Well, what does it mean? So first of all, it means that all the state accesses modifications will be either committed together or none of them will. Also, the events are emitted will be wrapped together. Within that, there will be either emitted atomically or not. Invocation will leave the state table in a consistent manner, and two concurrent invocations to this process function would be isolated from each other. So we'll not see like intermediate writes to the state access or anything like that. And the durability comes from whatever we already expecting from Flink state durability here. So, and I can execute it, but it will be pretty boring because we are transferring we are transferring funds between accounts that are all empty. So we'll actually look at the second example where we have also the deposit stream. So that example builds on top of the previous one. It has the same state declaration, same ledger name, and so forth. It has the transfer stream, and now the deposit stream, it's another data stream generated with in-memory generator, just for the sake of this example. And we are applying the deposit handler business logic, and note that we are using the same accounts definition. So we have two different streams sharing the same state. And I'll just quickly show what's going on here. So we just read the account balance, and we add whatever we have here in the specified in the event, and we write it back. So let me actually try to execute it. And so, okay. So what you would see here that at the beginning we'll have a bunch of failing transactions that obviously because there is still not enough funds, but in the background we have the deposit stream that transactionally adds funds, and you can actually see that some of the transactions already start to succeed because they have sufficient funds. And you can see that the source account balances and target account balances start to accumulate. So it is a very short session, so I think I will just briefly show the last example. Oops. Okay. Okay, I will not go into the details of the last example, but I just want to mention that it's not we can add arbitrary many states as well. So we can have accounts and assets, and in a single function, we can transact and move funds between those two tables with an asset guarantees. So I'd like to come back to the slides, and I want to say, so first of all, how do we get started here? So first of all, we are making the SDK available public, and it also contains a serial runner, so you can start and I don't know, validate if this maybe works for you and how it would work for you best. So we have a serial runner that you can play with and experiment, and we also have a parallel runner that is a part of the Data Artisans platform, the River edition, that it also has Flink, application manager, and the streaming ledger, the parallel runner. So at this point, I would like to maybe leave some time for questions. And yep.
Yeah, thanks a lot, Igal. Yeah, there are a lot of questions over there.
Can you explain what is a streaming ledger exactly? What is the model?
So I guess the best analogy would be, you can think about it as some sort of a table, maybe, that you can modify different rows of this table within your streaming application. So in reaction to live incoming data, stream data, you can change this kind of global table that you have within your streaming application. That's a really, really high level concept, if that's... Right. So it uses Flink state behind the scenes. So you will basically, yes. So you would basically insert records into a Flink state. So account in our example, that would be the account ID and the current balance.
Yeah, short one. The ledger, is this restricted to a single job, or will that run cross jobs?
So it runs with, okay. So if I understand your question correctly, so it can run across like job restarts, the same job, or job evolution of the same job. So you have a state just as a normal Flink state. So you can take a save point, for example, tear down the job, maybe modify it, add another deposit, another stream or something like that, and then you can just start from that save point. So if that answers your question. Okay.
We have time for one more question.
Can you show us how it looks in Flink GUI? What kind of Flink job it is?
Sorry?
Can you show us how these examples look in Flink GUI? What kind of Flink job it is? What kind of operators?
In the Flink UI, you mean? In
yes.
The GUI? Okay, sure. Yes. So, yes. So, let me run the previous example. Something going on here. So I'm using here the parallel runner, although it's on my local machine. So I will oops. Apple. So it looks like that. Similar to what you've seen probably this morning in the keynote. And so you have your incoming sources, might be from whatever, and then this is basically the box that corresponds to the streaming ledger. Okay.
All right. Thank you again, Igal. The rest of the Data Artists crew is also available at the booth if there are any more questions, and we also have the break. Probably you'll stay around a little bit. The next talk is in 10 minutes about monitoring Flink with Prometheus here, and see you then.